guys, I hope you all are fine, happy and healthy. Today we are going to do exercise 1.9, question number 1. In this question we need to find HCF of the following numbers. I am using factor tree method here. I'm going to prime factorize 48 and 108. This is part A. So I'm going to make prime factors of 48 first. With the help of factor tree method, and 108, 2 into 54, 108, and 2 into 27. So these are the prime factors of these two numbers, and now we'll check which numbers are common among the prime factors. First, we'll write 48 as a product of its prime factors, and then 108 as a product of its prime factors. Now we'll check which numbers are common between the two numbers. This 2 is common in both, and this 2 and this 3 is common. So we'll just write all the common numbers once and multiply them to get HCF of 48 and 108. Question number 2, same way. In part C, we are making prime factors of 72 and 90. Using factor tree method again. So we'll write 72 as a product of its prime factors and 90 as a product of its prime factors to see which numbers are common in both. Here 2 is common, 3 is common, so the HCF will be another 3 is common, yes. So it will be 2 times 3 times 3, 18. So 18 is the HCF of 72 and 90. Part D, 52 and 78. We'll do it in the same way. Almost all of the questions are same. The method is same. You can stop the video and try it yourself. It's pretty easy. If you want to prime factorize these numbers using any other method, it's up to you. There are many other methods of prime factorization. The factor tree method is a visual way to break down a composite number into its prime factors. and it always starts with the number at the top and branches out into different factors. Okay, part F 154. We'll split it into 2 and 77 and then split 77 into 7 and 11. Now we'll write all the prime numbers, the prime factors of 154, 54 and 88. And we'll take out the common ones. We'll write it once and multiply them to get highest common factor. Five 46 and 624. So that is 6 times 13, which is 78. Part H 95 and 120. Again, factor tree method. 5 times 19 is 95 and 19 is a prime number, so we cannot further split it. And then 120. Okay, so in question number 2, we have to find the LCM of all these numbers. I will use factor tree method here. 54 and 60. There's a slight difference in LCM and HCF using factor tree method. We'll jot down all the prime factors first. So now to find the LCM, least common multiple, we'll first take the common ones out, write them once. We'll pick out 2 and 3. These are common, and then the rest of them, and we'll write the rest of them as it is. You just have to write the common ones once only. And the rest of them like that. So 540 is the LCM of 54 and 60. LCM means least common multiple. Part B. There's another method of prime factorization that's called division method. You can also opt for it if that's convenient for you. In the end of this video, I'm going to do the division method also. You can opt for any of them, whichever you find easier. Okay, here in question number 3, we have to find LCM and HCF both. So I am using both methods, factor tree method and division method. First, I will do this question with the help of factor tree method. It's the same. And 108. I'm going to split it into prime factors. I'll keep splitting all the composite numbers until it all becomes prime. 3 times 9, 27, and 3 times 3 is 9. Now I am going to list down all the prime factors in order to find the LCM. division method, it actually starts with the given number and then we divide it by the smallest prime number, that is 2. And we will divide it evenly by 2. First, let us write the number 72, and then the smallest prime number, the prime factor of 72 and 108 is 2. So we'll divide it by the smallest prime number 2, and that actually 2 divides it evenly. That's why we are using this factor here. If it doesn't divide evenly by 2, try the next prime number 3, and so on. Students, you need to continue dividing the dividend until you reach the quotient of 1 on both numbers. So our LCM will be the product of these divisors, the prime factors. Now we'll find HCF in the same way by division method. So we'll just stop here because we don't have to reach quotient 1. We'll keep dividing until both numbers are coming in the same table. So 2 and 3, these are the numbers that are not coming in the same table. So we'll just stop here, stop the division here, and write down all the prime factors, the divisors, and multiply them.